Dear students, in this video I am going to introduce planes. So far we have seen the straight lines in the space. In the previous videos we have seen that the equation of straight lines in the space and also distance between the lines and skew lines and so on. Now in this video I am going to introduce planes. Planes in space in three dimensions. So first result is equation of a plane in normal form. Equation of a plane. This is our first bookwork. Equation of a plane in normal form. That is, this is your OX, three-dimensional coordinate system OX. This is x-axis, OY and OZ are the three mutually perpendicular coordinate axes, and I vector acting along x-axis, J vector unit vector, J cap is the unit vector acting along y-axis, and K cap is the unit vector acting along z-axis. And now OM is a normal vector. It is in the direction. ON is a normal vector passing through the origin. Its distance from the origin is D. Its distance from the origin is D. ON is D. And draw a perpendicular OP, NP, which is perpendicular to the normal line ON. And OP vector is your R vector. OP vector is this OP vector is R vector, and this is your plane. This is the plane. In this plane, ON is perpendicular normal to the plane, and whose distance from the origin is D, and N vector is the vector acting along the line ON. N vector NP is perpendicular to the normal line ON, and P is any point in the plane whose coordinates are x, y, z, and OP vector is R vector, and this is the plane represented. Use the equation you have to find out in normal form, because ON is the normal to the plane. Okay. Now, in this plane, in this required plane, ON is the normal to the plane whose distance from the origin is D. Whose distance from the origin, whose distance from the origin is D. Whose distance from the origin is D. whose distance from the origin is d. Okay. D into n. dn is the vector, normal vector. dn is the normal vector. dn is the normal vector yn. dn vector is the normal vector acting along yn, and np vector is perpendicular to yn. np is perpendicular to the yn vector. So np vector happens, p is any point on the space. P x, y, z is any point in the plane. P x, y, z is any point in the plane, and OP vector equal to R vector. It is defined by xi vector plus yj vector plus zk vector, where xy, z are direction ratios of vector OP. xi plus yj plus zk is the OP vector R vector. X, y, z are the direction ratios of the vector OP, and np vector you know by definition. np vector is equal to OP minus ON. You know OP vector is R vector minus ON vector. You know ON vector is D into n vector. Distance D into n vector. np vector OP minus ON. ON is D into n, R minus D into n. Now np, ON and np are perpendicular. Since ON is perpendicular to np, np dot ON equal to, since ON is perpendicular to np, np dot ON np dot yn equal to 0, because np and yn are perpendicular, their dot product is 0. np dot yn equal to 0 because yn and np are perpendicular. Therefore, np dot yn equal to 0. You know, np is r minus dn, d into n vector dot yn is d into n vector equal to 0. You divide by d, the scalar d to the right hand side, it becomes r minus d into n vector dot n vector equal to 0. So n cap is unit vector acting along the d into n cap is the normal vector. We write it, it's not a unit vector. d into n cap is the unit vector acting along the normal vector yn. So you will write it as a n cap is the unit vector, not n is any vector, because n cap is the unit vector. N cap is the unit vector acting along the direction of yn. So yn is r minus d dot n cap only, not n vector. So yn vector is d into n cap. So n cap is the unit vector acting along the direction yn. The distance yn is d. So this is d into n cap r minus d into n cap is equal to dot d into n cap equal to 0. This is d. You divided the scalar d to the right hand side by divide by d on both sides, you will get r minus d into n cap dot n cap equal to 0. Now multiplying with n cap, r dot n cap minus d into n cap dot n cap equal to 0. N cap dot n cap is 1 because n is unit vector. So this is r dot n cap minus d equal to 0 or r dot n equal to d. From this step I will get r dot n cap equal to d. This is the normal equation of the plane. Sorry, normal equation of the plane, where d is the distance of the perpendicular distance of the plane from the horizon. R dot n. From this step I will get r dot n cap equal to, you bring the d to the right hand side, it becomes r dot n equal to d. So r dot n cap equal to d is a normal form of the equation, where n cap is the unit vector acting along y and r dot n cap equal to d. Okay. Now n cap is defined by, that's all about the problem. Normal equation of the normal form is r dot n cap equal to d, n cap equal to d. Remember. Now, where n cap is a unit vector defined by xi plus mj plus nk, where l, m, n are the direction cosines of the normal vector. See, now n cap vector equal to, n cap is defined by li plus mj plus nk vector, where l, m, n are DCs of the normal vector, unit normal. Unit normal n cap, and the LMN are the DCs of the unit normal n cap. Therefore, its Cartesian form of the equation. This is a vector form, r dot n cap equal to d is the vector form of the normal equation, and Cartesian form is r dot n cap equal to d, you know, where d is the distance of the plane from the horizon, perpendicular distance of the plane from the origin. The Cartesian form is, you know, the r dot, not in this vector form, Cartesian form you have to find out. Vector form, you know, r dot n cap equal to d, or you know, xi plus yj plus zk dot, n vector is li plus mj plus nk equal to d. By taking dot product I dot I1, therefore you get lx plus my j dot j1 plus k dot k1 nez equal to d. Lx plus my plus nez equal to d is the Cartesian form, normal equation of the plane in Cartesian form. Our Cartesian equation of the plane in normal form is Lx plus my plus nez equal to d, where L, M, N are the direction cosines of the normal vector, and d is the distance, perpendicular distance of the plane from the horizon. Okay. Suppose if the n vector, any vector, if n is any vector, suppose A, B, C are DRs, direction ratios. So writing this, A, B, C are the DRs of the direction ratios of normal vector if n, here normal vector n. So n vector is ai plus bj plus ck. So a, b, c are the direction ratios of normal vector. Therefore, it is defined by n vector. So n cap equal to, n cap equal to n vector by mod of n vector. Therefore, n cap is this. So you know the formula for n cap. If it is normal form, if direction ratios are given a, b, c, the formula is r dot n cap equal to t, where n cap equal to n vector by mod n vector equal to t. This is r dot. If direction ratios are given, n cap is n vector by mod n vector equal to t. Okay. D is the perpendicular distance of the plane from the origin. So from this we have r dot n vector equal to d into mod n vector. You bring this mod into the right hand side, it becomes d into r dot n into r dot n equal to d into mod n vector, or d into mod n corrected as q. So r dot n equal to q. It's also the equation of the plane where n is any vector and q is not the perpendicular distance from the origin. Q is any distance. It's not a perpendicular distance from the origin. So n r dot n equal to q is the vector equation of plane. Vector equation of the plane. N is any vector where n is any vector and q is not the perpendicular distance. Q is not the distance from the origin. Q is any distance. Q is not the perpendicular distance from the origin. To convert into normal form, you get it, you divide both sides by mod n. To convert into the normal form, A, B, C are the direction ratios. So this equation becomes Cartesian form of the plane is Cartesian form of the plane r dot n equal to q. D into mod n is q. Now r is xi plus yj plus zk dot n. N vector is any vector ai plus bj plus ck, because n vector is not a unit vector. A, B, C are the direction ratios of n vector equal to q. Therefore, this is the general equation of the plane. Cartesian form is x dot I dot I1, you get Ax plus By plus Cz equal to Q. That is, if you divide both sides by, if this is the Cartesian form of the equation. Now, the general plane equation converted into Cartesian form. If A, B, C are direction ratios, we get Ax plus By plus C is equal to D. In note, you consider this. If R dot n is any equation, R dot n equal to, what is that? Q. Or Q, you know, D into mod n. Q is equal to D into mod n. Therefore, D, if you want D equal to Q by mod n. This is D into mod n is Q. So, D if you want from this, Q by mod n. So, you divide both sides by mod n, you will get R dot n vector by mod n vector. If any equation given R dot n equal to Q, R dot n vector by mod n vector by Q by mod n. Divide both sides by mod n, modulus of n vector, you will get R dot n by mod n. It is nothing but R dot n by mod n is n cap equal to Q by mod n is D. So this equation R dot n cap equal to D, it converted. This equation, any equation converted into normal form like that. If you divide both sides by mod n, you will get the equation in normal form. R dot n cap equal to D. So this is a relation converting any equation into normal form, where using this idea Q equal to D into mod n, where from that perpendicular distance from the origin D, if you want to divide Q by mod n, you will get D, the perpendicular distance from the origin. That's all about the problem. Sorry, that's all about the Cooper in normal form, and any if direction ratios are given and that equation is converted into normal form. Now you see the problem, one problem I am going to solve. Find the vector equation of the plane which is at a distance 6 by root 29 from the origin. You consider this problem. Find the vector equation of the plane. See, I am explaining how we convert an equation into normal form and how to find the perpendicular distance of the plane from the origin. These are the ideas. For using these ideas, we are going to solve the problems now. The first problem, C. Find the vector equation of the plane which is at a distance 6 by root 29 from the origin. And its normal vector from the origin is n vector is given by 2i minus 3j plus 4k. Find the vector equation of the plane. Find the vector equation of your plane. Find the vector equation of a plane whose distance from the origin is whose distance from the origin is 6 by root 29 and its normal vector it's not unit vector, it's normal vector from the origin is n vector, it is given by 2i minus 3j plus 4k. So find the vector equation of the plane whose distance from the origin is 6 by root 29 and its normal vector from the origin is n vector. So you know formula of the vector equation of the plane is r dot n cap equal to d. This is the vector equation of the plane in normal form. R dot n cap equal to d. And if when n is any vector, it is given by r dot n equal to q. Okay. Now, r vector dot n vector is 2i minus 3j plus 4k equal to q. Q distance from the origin 6 by root 29. So you convert this is n vector, you convert this into unit vector, you get r vector equal to r dot n cap. N cap is 2i minus 3j plus 4k by mod of this is 2 square plus 3 square plus 4 square equal to 6 by root 29. Okay. Now r dot, the distance is given by 6 by root 29. You convert this into a n cap. So r dot n cap is 2i minus 3j plus 4k divided by 16, 20, 29, root 29 equal to 6 by root 29. So r dot n cap equal to d. This is d. Now you can simplify this as r dot 2i minus 3j plus 4k equal to, you bring this root 29 to the right hand side, it becomes 6. So r dot 2i minus 3j plus 4k equal to 6. This is the vector equation of the plane in normal form. That's all about the problem. Suppose if you want to find out the Cartesian equation, just you consider r by xi plus yj plus zk. Therefore, Cartesian equation is, this is not asking in the problem, so I can explain Cartesian equation also. Cartesian equation is r is xi plus yj plus zk dot 2i minus 3j plus 4k equal to 6. That is I dot I1 2x minus 3y plus 4z equal to 6. This is your Cartesian equation. So this is vector equation and this is Cartesian equation of the plane. That's all about the problem. So I will stop here and we will continue the next problem in the next video. Thank you.